Now let's practice solving exponential equations using the two-column table. I'll run the first one. I have two operators. I have an exponential and I have subtraction. If t was a value, I would simplify the exponential first and then I would subtract. So my table will have two rows. The left column will be for my operations and the right column will be for my inverses. Now, starting in the original, I need to do the inverses. That is, I'll add 2,000 and simplify. And then to undo e to the t, I will take the natural log, since my base of e needs to match the base of the inverse operator. After taking the natural log of both expressions and simplify, I find my answer. I'll return to the original, substitute my answer. Remember that e with an exponent of log base e will simplify to the argument. Both sides become the same value, so I'm comfortable that my answer is correct. Here's one for you. We would do 10 to the t first and add second, so that's going to be the order in our left column. Here are the inverse operators in the right column. I remember to use log because the base of my original is a 10. I start at the bottom of the right column, return to the original, subtract 150,000 from both expressions and simplify. Then I take log base 10 of both expressions and simplify. Here's my solution. To check my work, I return to the original. I substitute for t with my answer. 10 with an exponent of log base 10 of 350,000 can be replaced simply with the argument. And after adding, my values match, so I'm confident in my work. How about here? This time we have three operators, 1, 2, 3. If x was a number, I would first find e to the x, and then I'd multiply by 2, and last I would subtract 4. Here are my inverse operators. Again, I want to use ln because my original base was e. Returning to the original equation, I'd first add 4 and simplify. Next, I'd move up a row and divide by 2 and simplify. I'd move up a row, take the natural log of both expressions and simplify. My answer would be natural log of 16. So I return to the original equation. I substitute. I have e with an exponent of log base e of 16, which can be replaced simply with 16. I continue to simplify. My values match. I'm comfortable. My work is good. How about here? Again, there's three operators, and if x was a number, we would find e to the x first, we'd multiply by a half second, and we'd add third. So that's going to be my left column. In the right column, I'll write my inverses. This one's a little different at first for some people. The inverse for multiplying by a half is multiplying by 2. Because if we multiply a half and 2 together, we'll get 1 times e to the x, which can just be replaced with e to the x. Starting from my original and the bottom of the right column, I'll subtract 1 and simplify. I'll multiply both sides by 2, and you see what's going to happen right here? I'll just get 1 times e to the x. Of course, on the right I'll get 40. Then I'll move up a row. I'll take the natural logarithm of both expressions and simplify. Recall that log base e of e to the x can simply be replaced by the exponent. Here's my answer. I return to the original. I substitute, I simplify. Both expressions are 21. I'm confident my work is good. How about here? If x was a number, I'd first find 10 to the x, and then I would multiply by 5, and last I would subtract 90. So that's going to be the order in the left column. In the right column, I would add 90, divide by 5, and find the common logarithm since my original base was a 10. Starting with the original, I'll add 90 first and simplify, divide by 5 and simplify, take the common logarithm of both expressions and simplify, and here's my solution. I'm now going to return to the original. I'll replace x with my solution. 10 with an exponent of log base 10 with an argument of 20 can be replaced simply with the argument. I'll continue to operate. I'll find both expressions become 10, and that convinces me my answer is a good one. And here's our last one. In this case, I have 1, 2, 3 operators. The exponential will be first, subtracting will be second, dividing last. So in my table, I'll have 3 rows, and exponential is first, subtraction second, dividing third. Here are my inverse operators. I'll remember to use log again since my original base was a 10. I start with my original. I start at the bottom of the right column. I'll multiply 2 to both expressions. These 2's reduce. So I can simplify to 10 to the t minus 75 is 200. I'll move upper row, add 75 to both sides and simplify. I'll move upper row and take the common logarithm of both sides and simplify. Here's my answer. I check my answer. It looks good. This then is my solution. Well, that will conclude this video where we've practiced solving exponential equations using the 2-column table.